Inside the atom. Exercise page 38. Inside the atom. Exercise page 38. Exercise Q1.1, page 38. Answer the following. What is the difference in the atomic models of Thomson and Rutherford? Solution. Thomson theory. Rutherford theory states that electron is embedded in a positively charged solid material which is spherical in shape. States that an atom is composed of an atomic nucleus around which electrons are revolving in an orbit. Does not give any detail about the atomic nucleus. Explains about the atomic nucleus. States that electrons are uniformly distributed in an atom. States that electrons are located around a central solid material. Indicates that the atom is spherical in shape. Indicates that an atom has a central solid core called a nucleus surrounded by the electrons. Does not give any idea about constituents of the nucleus. States that the nucleus is composed of protons and neutrons. Exercise Q1.2, page 38. Answer the following. What is meant by valency of an element? What is the relationship between the number of valence electron and valency? Solution. Valency of an element. It is the number of electrons of an atom of the element uses to combine with atoms of other elements. It is the combining power of an atom of the element. Valency of an atom is determined by its electronic configuration. It gives idea about the number of electrons lost or gain in order to achieve the nearest noble gas configuration. For example, Na 11 equals 2, 8, 1, so its valency is 1 Cl 17 equals 2, 8, 7, so its valency is also 1. Number of valence electron. It is defined as the number of electrons present in the outermost shell of an atom. It is not necessary that all the valence electrons take part in bonding. For example, Na 11 equals 2, 8, 1, so its number of valence electron is 1 Cl 17 equals 2, 8, 7, so its number of valence electron is 7. It can be seen that valency of an element is related to number of valence electrons in that atom. Exercise Q1.3, page 38. Answer the following. What is meant by atomic mass number? Explain how the atomic number and mass number of carbon are 6 and 12 respectively. Solution. Atomic mass number. It is the sum of total number of protons and neutrons present in a nucleus. Atomic mass number equals number of protons plus number of neutrons. Atomic number equals number of protons equals number of electrons. It is denoted by Z. Mass number equals number of protons plus number of neutrons. It is denoted by A. For example, carbon atom its number of proton equals 6, number of neutrons equals 6, number of electron equals 6, atomic number Z equals number of protons equals number of electrons equals 6. Mass number A equals number of proton plus number of neutrons equals 6 plus 6 equals 12. Exercise Q1.4, page 38. Answer the following. What is meant by subatomic particle? Give brief information of 3 subatomic particles with reference to electrical charge, mass and location. Solution. Subatomic particles. A subatomic particle is a structural and functional unit of the matter. That means all the matters are made up of these fundamental particles. According to modern atomic theory, an atom has a nucleus, which is present in its center or core. These nucleus contain subatomic particles like protons and neutrons. Difference between subatomic particles are as follows. Electron 1. Electrons are present outside the nucleus of an atom. 2. Electrons are negatively charged, that is 1.6 times 10 to 19 coulomb. 3. The mass of an electron is considered to negligible. It is 1800 times less than that of a hydrogen 4. Relative mass equals 1/1840th times hydrogen 5. It revolves around the nucleus in the discrete orbit. Proton 1. Protons are present in the nucleus of an atom. 2. Protons are positively charged, that is 1.6 times 10 to 19 coulomb. 3. The mass of a proton is approximately 1 U, 1 Dalton, that is 1 U equals 1.66 times 10 to 27 G. 4. They are closely bound in the nucleus. Neutron 1. Neutrons are present in the nucleus of an atom. 2. Neutrons are neutral. There is no charge. 3. The mass of a neutron is nearly equal to the mass of a proton, that is 1 U, 1 Dalton, that is 1 U equals 1.66 times 10 to 27 G. 4. They are closely bound in the nucleus. Exercise Q 2.1, page 38 gives a scientific reason. All the mass of an atom is concentrated in the nucleus. Solution. All the mass of an atom is concentrated in the nucleus because atom contains 3 subatomic particles like electron, proton and neutron. Out of which, nucleus present at the center of an atom contains 2 subatomic particles, that's protons and neutrons, and the mass of nucleus is the sum of mass of protons and neutrons located at the center of an atom. Exercise Q 2.2, page 38 gives a scientific reason. Atom is electrically neutral. Solution. Atom is electrically neutral because in an atom electrons and protons carry charges and each atom has equal numbers of protons positively charged, and electrons negatively charged. Exercise Q 2.3, page 38 gives a scientific reason. Atomic mass number is a whole number. Solution. Atomic mass number is a whole number because it is the sum of numbers of protons and numbers of neutrons present in an atom, which is present in the form of integers. Exercise Q 2.4, page 38 gives a scientific reason. Atoms are stable though negatively charged electron are revolving within it. Solution. Atoms are stable though negatively charged electrons are revolving within it because each atom contains equal numbers of protons and electrons. So, charge on negatively charged electrons are balanced by charge on positively charged proton. Therefore, atom is electrically neutral and stable. Exercise Q 3.1, page 38 define the following form. Atom. Solution. An atom is defined as the structural and functional unit of a matter. The term atom comes from the Greek word which means indivisible, because atoms are the smallest things in the universe and could not be divided. Atoms are made up of 3 subatomic particles like protons, neutrons and electrons. Exercise Q 3.2, page 38 define the following form. Isotope. Solution. Isotopes are atoms that have same atomic number but different mass number. Isotopes have same numbers of protons but different numbers of neutrons. These are some common examples of isotopes. 3,2He, 4,2He, 12,6C, 14,6C, 235,9,2U, 239,9,2U, 289. Exercise Q 3.3, page 38 define the following form. Atomic number. Solution. The number of protons in the nucleus of an atom, which is characteristic of a chemical element and determines its place in the periodic table. Atomic number is also equal to numbers of electrons in an atom. For example, atomic number of carbon equals 6, atomic number of nitrogen equals 7, atomic number of oxygen equals 8, atomic number of magnesium equals 12. Exercise Q 3.4, page 38 define the following form. Atomic mass number. Solution. It is the sum of total number of protons and neutrons present in a nucleus. Atomic mass number equals number of protons plus number of neutrons. Atomic number equals number of protons equals number of electrons. It is denoted by Z. Mass number equals number of protons plus number of neutrons. It is denoted by A. For example, carbon atom its number of proton equals 6, number of neutrons equals 6, number of electron equals 6. Atomic number Z equals number of protons equals number of electrons equals 6, mass number A equals number of proton plus number of neutrons equals 6 plus 6 equals 12. Exercise Q 3.5, page 38. Define the following form. Moderator in nuclear reactor. Solution. Moderator of a nuclear reactor is a substance that slows down the speed of neutrons. In traditional nuclear reactors, the moderator is the same thing as that of coolant like water. Exercise Q4.1, page 38. Draw a neat log diagram Rutherford's scattering experiment. Solution. Exercise Q4.2, page 38. Draw a neat log diagram Thomson's atomic model. Solution. Exercise Q4.3, page 38. Draw a neat log diagram diagrammatic sketch of electronic configurations of magnesium, atomic number 12. Solution. Exercise Q4.4, page 38. Draw a neat log diagram diagrammatic sketch of electronic configuration of argon, atomic number 18. Solution. Exercise Q5.1, page 38. Fill in the blank. Electron, proton, neutron are the types of underscore in an atom. Solution. Electron, proton, neutron are the types of subatomic particles in an atom. Exercise Q5.2, page 38. Fill in the blank. An electron carries a underscore charge. Solution. An electron carries a negative charge. Exercise Q5.3, page 38. Fill in the blank. The electron shell underscore is nearest to the nucleus. Solution. The electron shell K is nearest to the nucleus. Exercise Q5.4, page 38. Fill in the blank. The electronic configuration magnesium is 2, 8, 2. From this it is understood that the valence shell of magnesium is underscore. Solution. The electronic configuration magnesium is 2, 8, 2. From this it is understood that the valence shell of magnesium is M shell. Exercise Q5.5, page 38. Fill in the blank. The valency of hydrogen is 1 as per the molecular formula H2O. Therefore valency of Fe turns out to be underscore as per the formula Fe2O3. Solution. The valency of hydrogen is 1 as per the molecular formula H2O. Therefore valency of Fe turns out to be 3 as per the formula Fe2O3. Exercise Q6, page 38. Match the pairs. Group A. Group B. A. Proton I. Negatively charged B. Electron 2. Neutral C. Neutron 3. Positively charged. Solution. Group A. Answer A. Proton 1. Positively charged B. Electron 2. Negatively charged C. Neutron 3. Neutral. Exercise Q7, page 38. Deduce ED from the datum provided. Solution.